Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today we're going to talk about an example that has to do with energy conservation and circular motion and projectile motion. Here is an example from past exam. A 0.1 kilogram block is released from rest at point A as shown, a vertical distance h above the ground. It slides down an inclined track around a circular loop of radius 0.5 meter. Then up another incline that forms an angle of 30 degrees with the horizontal. The block slides off the track with a speed 4 meters per second at point C, which is at a height of 0.5 meters above the ground. Assume the entire track to be frictionless and air resistance to be negligible. Determine the height h. So here is a concept of conservation of energy. Because the track is frictionless, so the only force doing work is gravity in this case. Normal force, we know it doesn't do any work because normal force is always perpendicular to the displacement. Since the total energy at A has to be equal to total energy at C, we know the height of C, we know the speed of C, so we know the total energy of C. That's how we can find total energy at A. At A is just mgh. So, because the track is frictionless, total mechanical energy is conserved. So the total energy at point A, which is mgha, equals to the potential energy at C plus the kinetic energy at C. HA, we cancel out m and divide by g on both sides. So HA equals hc plus v squared over 2g. HA is just h, and that equals to 0.5 plus 4 squared divided by 2g. H equals to 1.3 meter. Next one, on the figure below, draw and label all the forces acting on the block when it is at point B. So at point B, there's definitely gravity force also because it's against the track is pushing it to the left. So there are two forces, and this is the track pushing the block. We call that normal force. The other one is gravity. Part C, determine the magnitude of force exerted by the track on the block when it is at point B. So what is this N? So because the object is moving inside a circle, so it's moving a circle, it must have a centripetal force. And that centripetal force in this case is provided by the normal force. Normal force equals to centripetal force. So centripetal force equals mv squared over r. What is v? Since B and C have the same height and they have the same energy, therefore they must have the same speed. So v equals to 4 meters per second at point B as well. We substitute it in, so Fn equals to 3.2 Newton. Next one, determine the maximum height above the ground attained by the block after it leaves the track. So here is the block. What it's going to do is this now becomes a projectile. So they are asking you, what is this height right over here? This is kinematics. The height is in the vertical direction. So let's see, we say up is positive, and to the right is positive. Up is positive. At highest point, we know vertical velocity equals to 0. So we can use this equation because we can figure out, we know the speed over here, we can figure out its vertical component at point C. We also know acceleration is negative g. It's negative g because acceleration is downward, therefore it's negative. We know Vfy equals to 0, that's how we find delta H. Viy equals Vi sine theta, so Viy is 4 times sine 30, the whole thing squared plus 2g delta H, and you can solve for delta H. Delta H is the displacement above point C, and that's not what they are asking. They are asking above the ground. So you have to add the 0.5. So the maximum height above the ground is 0.7. E, another track that has the same configuration but is not frictionless, is used. With this track, it is found that if the block is reached to point C with a speed 4 meters per second, the height must be 2 meters. So before we know, without friction, it's 1.3 meters. Now you need 2 meters. How much work is done by the frictional force? So we said, according to work energy theorem, total work done by the other force equals to change in total energy. So the total energy or total mechanical energy in here, just mechanical energy at C minus mechanical energy at A. Mechanical energy at C is its kinetic plus its potential. At point A is just the potential. Again, it is dropped like from rest. So we substitute everything in. We know what M is. We know VC equals to 4. We know H at C is 0.5. We know HA is 2. So you substitute everything in. M is 0.1. So you can have work equals to negative 0.7 joules. It's negative because it's friction. Friction always does negative work. It takes energy away from the system. That's it for today. Thanks for watching.